Hello everyone, I'm Mark. Good morning or good afternoon, depending on where you are in the world. First off, on behalf of JS Solar, a leading global manufacturer of high-performance photovoltaic products, and our guests representing Riot's Energy, Huawei, and TÜV, thank you for showing interest and support in this webinar for Australian solar market. The focus of today's webinar is to showcase and discuss the exemplar progress of Australia's rapidly growing photovoltaic market, as well as providing insight on the latest and most advanced module, inverter, energy storage, and tracker technologies. We're going to jump right into it as we have an informative session today. Please leave your questions in the Q&A section as they come up, and our panelists will answer as many as possible at the end of today's session. First, regarding the Australian solar market, we have Mr. Stephen Chan, Assistant President of APAC and Middle East from JS Solar with us today.
Dear customers, welcome to today's webinar for the Australian market. I'm Stephen Chan, responsible for JS Solar's commercial activities in the Asia Pacific region. Australia is no stranger to JS Solar. Actually, our relationship with Australia goes back to 2005, when a group of Australian experts was invited to participate in the establishment of the company. In 2013, the JS Solar Australian subsidiary was created. Over the years, JS Solar has overcome many challenges to emerge as one of the leaders supplying and servicing the Australian market. Basking in the sun, the potential is great for Australia to developing its PV market. As of 2022, Australia is the 7th largest PV market in the world, according to IHS Markit. The country's goal of 43% emission reduction by 2030, based on 2005 levels, underpins our confidence in developing the solar power market here in the coming decade. As the industry leader in supplying and servicing the solar PV market, JS Solar always tries to provide the most efficient and reliable products and services to global customers. In 2020, our DeepBlue 3.0 module was launched, which is recognized worldwide with the cumulative shipments reaching 24 gigawatt at the end of June this year. To further reduce LCOE and increase customer value, we will soon introduce our DeepBlue 3.0 Pro and N-Type DeepBlue 4.0X modules to the Australian market. Later, my colleagues will give a detailed introduction to these advanced products. In Australia, our business covers the residential, C&I, and utility scale markets. We go to market with the networks of leading distributors, retailers, EPCs, and large solar farm developers. We continuously strengthen our commercial and technical team to deliver a best-in-class customer experience and optimal solutions to our partners and customers. This is all supported by our dedicated and experienced local sales and technical teams, together with our back-end support team in China. Furthermore, our Australia subsidiary has third-party logistic warehouses across 5 major capital cities to provide value-added local logistics support.
Pleasure.
Customers, thank you for your trust in making JS Solar your business partner. Let's work together to further promote the development and deployment of solar energy in Australia. Thank you again for joining us, and please enjoy the webinar.
Thank you, Stephen, for your warm welcome and introduction. Now, to introduce large-scale solar advantages, we welcome Cameron Munro, Business Manager at JS Solar, large-scale solar consultant with more than 20 years of executive leadership, business development, project management, and engineering consulting experience. Business leadership in sales, marketing, finance, distribution, development, engineering, installation, and manufacturing with national teams. Nice to have you with us, Cameron.
Thank you, Mark, and thank you all for joining today's webinar. I'll start my presentation. Okay, so some background on JS Solar. JS Solar was formed in 2005 and was listed on the NASDAQ in 2007. We've also been listed on the Shenzhen Stock Exchange in 2019. We have over 29,000 employees, and our turnover in 2021 was over 6 billion USD. As of Q1 this year, we've shipped a cumulative 95 gigawatts of solar panels to over 135 countries and regions. We have 12 manufacturing bases, and we currently have 14% global market share of solar panel supply. We're listed as a Fortune China 500 company, and we're ranked number 2 in terms of global shipments of solar panels. So JS Solar is a vertically integrated company. In terms of our manufacturing, we have 40 gigawatts of ingot manufacturing capability, 40 gigawatts of wafers, cells, and 50 gigawatts of modules. We also develop solar power plants. Those different manufacturing steps are covered across a large number of factories across different regions. That provides us the flexibility and the certainty of supply, which means our customers can rest assured that they're going to receive their modules as promised. In terms of our company values, our mission is to develop solar power to benefit the human race. Our core values are to always put the customer first, to respect shareholders' interests, and let our employees grow. Our attitude is for integrity and professional ethics. Our vision is being a great enterprise, which is what we are. And our spirit is sincerity, simplicity, reverence, and gratitude. So JA Solar every year strives to improve our technology. So you can see on this timeline here, back in 2011, we achieved 18.8% cell efficiency in mono cells. And then every year since then, we have progressively improved the technology. Most recently in 2021, we achieved a 23.4% efficiency with the Perseum P-type cells, and we set up our pilot line for the Bison N-type cell production. That line is now in operation and is supplying modules to the different regions that we supply to. You can see here on the map of the world that we have branches across the globe, and we have warehouses at very strategic locations, including in Australia. Our warehouse in Australia provides certainty of supply when projects need to be started quickly. We have those modules in country. In terms of where we ship to, you can see a comparison pie chart there on the right-hand side. So globally, the shipments distributed like 33% in China, 23% in America. Our share of those shipments, of those global shipments, is fairly well proportional to the actual market. We strive to set up strategic partnerships with project developers, EPC companies, and project owners. You're probably familiar with some of the names on the list here, likes of FRV, Acciona, Epidrama. And we strive to set up long-term support of those companies and their projects to ensure that there's success. In terms of international accreditations, we've won the top brand PV seal from EUPD research for many years consecutively. You can see different regions of the globe where we've won that award. That includes Australia, different parts of Europe, and Asia and South America. And we also have accreditations from the likes of TÜV and other industry bodies. JA Solar is a highly bankable company. Our modules are highly bankable. In 2021, we were ranked AA bankability rating by Bloomberg, and that put us head and shoulders above our competition. It's a very important point, this, in terms of achieving project finance. Having a very highly bankable module can go a long way. In terms of social responsibility, JA has donated to many causes, including the COVID-19 epidemic response. We donated medical equipment. We have donated for people to be able to have cataract surgery. We have donated for food, for flood relief. We've built schools. And also we have donated solar power systems to impoverished people.
Cameron, I'm really sorry for interrupting you, but it seems to that we have a technical issue. We can't really see your PPT.
Yeah, I'm not sure. It's up on my screen, so I'm not sure what's happening with that.
Yeah.
Anyway, I think I'll just keep going, and you can work that out later.
Yeah, have you shared it?
Yes, it's shared.
Yeah. All right.
So JA Solar stands against modern slavery. We have registered our modern slavery statement with the Australian Border Force, and our company has a task force to ensure that compliance with modern slavery policy. We've taken proactive measures to continuously improve and monitor and report on modern slavery. In terms of awards, we've won many awards in terms of our work with charities, with sustainability, and ESG, and we were ranked the best happiness enterprise award in 2021. Australia, in terms of Australian projects, JA has been completing or supplying to projects in Australia for a long time. I'm not sure if you can see my screen, but the first project here is based in Queensland, 2016, 25 megawatts. We supplied to the Moree solar farm, which is 70 megawatts back in 2016. The Griffith, New South Wales project of 36 megawatts. Darling Down, Queensland project, 136 megawatts back in 2018. The 148 megawatt project at Ross River, Queensland. And another project in New South Wales is 141 megawatts. Gunnawarra in Victoria was 60 megawatts was supplied in 2019. And South Australian project here was 154 megawatts supplied in 2020. And most recently, the Avonlea project in New South Wales of 245 megawatts, which is currently under construction with Beyond. Globally, we've supplied to many projects. Some examples are shown on screen if you can see it. It's a 550 megawatt project in Vietnam in 2020. A project here in Hungary, 54 megawatts in 2020. 490 megawatt project in China, and another project here in Cambodia. So you can see there's a long list of, I haven't obviously just a short list, but compared to the total number of projects that JA supplied to, you can see a long list of impressive projects that have, some of them that have been operating for quite a long time. In terms of large scale solar advantage, key points here are bankability, being AA rated with a turnover of $6 billion USD. The company and the products are highly bankable. We have a very long successful track record since 2005, and that's in Australia and internationally. We have 50 gigawatts of production capacity with multiple supply chain options in terms of different factories in different regions, which means that if there is some sort of disruption, that we can alter the plan to source from a different area that's not being affected by a lockdown or something like that. We're vertically integrated, as I went through before. You know, we produce ingots, cells, wafers, and modules. We have a very strong local team in sales, in technical support and logistics. And our technical manager will be presenting after me, Andrew. So that should be good. We also provide very high quality, high performing products, and the DeepBlue 182 millimeter wafer modules are key to that. Just some quick points on the 182 wafer modules. The 182 wafer module is an industry standard. There are other companies producing that same size wafer and similar module format. What that means is that JA Solar's modules are interchangeable with some other companies' modules. That provides EPC contractors and project owners the flexibility to change plans if need be in future, and have that certainty of supply, not only just in terms of JA's vertical integration, but also that there are other options in the market that would be similar. Maybe not as good, but similar. JA's modules have a very high mechanical strength to endure wind loads and prevent hail damage. This has been achieved by JA optimizing the 182 wafer technology. So they had a choice to go bigger or smaller, and they've optimized it at 182. That's provided a lot of benefits in mechanical strength and hail resistance. Also, another benefit is the superior packing, shipping, and manual handling, with a lower risk of damage and worker injury. The modules also have a higher safety margin to prevent current overload, and that's been achieved because they operate at a lower current to some of the other modules on the market. The lower current also has the effect of having a lower operating temperature and an increased power output. So overall, this means that there's a lower LCOE with lower cost, greater efficiency, higher power generation, lower degradation, and higher reliability. So that's it from me. Thank you. Thank you all.
Thank you, Cameron, for your insightful presentation. And moving forward, we have David Dixon with us, Senior Analysis from Rightset Energy. David is responsible for Rightset coverage of the Australian utility-scale renewables market research, including management of Rightset database of renewable assets in Australia, research into market trends, product development, and supporting Rightset's clients in Australia since 2018. He will tell us the trends, opportunities, and challenges in Australian renewable market.
Fantastic. Thanks a lot for the introduction, Mark. And maybe just to confirm that you can see my screen before I proceed, that would be great. Okay, well, perhaps I'll proceed, and if you let me know if you cannot see my screen, I'll continue through the presentation. So first off, I'd like to thank...
we can see. Thank you.
Okay, fantastic. Yeah, fantastic. So thanks to JA Solar for organising and inviting me to speak today. For those that don't know, Rystad Energy, we're an independent research firm headquartered in Oslo with analysts all around the world. I am part of the renewables team and I cover the Australia utility scale renewables market. We essentially have a database of all utility scale solar, wind, storage and hydrogen electrolyzer assets globally, and data pertaining to these assets, including project timelines, capacity, technology, stakeholders, PPA data, generation data and economics. And that's essentially where all the presentation graphs and charts come from today. So please email me if you have any follow-up questions. Moving on to the presentation. So today I'll give you an overview just of the utility scale renewables market in Australia, the build, the key participants in the utility PV market, and just some of the high-level challenges and opportunities that we see coming forward in the near term in the Australian markets. So moving on to the first part of the presentation. So what you see on screen here is the total pipeline of utility scale solar, wind, storage, hydrogen electrolyzer assets in the Australian market as of the 13th of June last year. So for every asset in our database, and at the time here, you can see there was 1,112 assets in our database. We classify them into one of 6 development life cycle categories that you can see in the bottom right-hand corner of your screen. Concept being the earliest stage of development right through to operating. So in Australia, that's an asset that's finished its whole point testing, which is a commissioning process in Australia. As of June last year, there was 247 gigawatts AC in the pipeline if you combine all the different technologies from over 1,000 assets, and we had 15.3 gigawatts AC of utility PV and wind energized. Traditionally, we add about 50 gigawatts a year to our database for Australia. That's roughly about a gigawatt a week in terms of new projects being proposed. But last year or over the past 12 months, that has grown substantially. So here is what the image looks like today. There's over 400 gigawatts at various stages of development. We now have 1,349 different assets, and we have 18 gigawatts AC of utility PV and wind energized. And just to note, there's another 6 gigawatts AC of utility PV and wind at various stages of construction and commissioning at the present time. It's also worth noting that utility PV is defined by us as 1 megawatt AC and ground mounts. So we do not include rooftop PV, which is a very significant portion of the market in Australia in any of these figures. In terms of the number of assets in the Australia market, over 650 of these assets that you see on screen are associated with utility PV. It's by far and away the most popular technology when it comes to the number of assets. And as you can see here, it's one of the top technologies when it comes to the amount of capacity. Next is onshore wind at about 280 assets. And then third is lithium-ion batteries at 235 assets. We also perform, as part of our work at Rystad Energy, our own analysis for clients, which they access in the form of reports. One of our most popular reports is always the look ahead for the coming 12 to 18 months that we publish at the start of the year. And here is an image that we are just taking from that report, where we essentially lay out what we believe will be the assets that will start construction over the next 12 to 18 months. So short-term, measurable, actionable projects. And here what you're seeing on the left-hand side is the onshore wind assets, and on the right-hand side is the utility PV assets. And how do we distill this information of over 1,300 assets into the ones that we believe will start construction? We engage the markets, we talk to which will go ahead. For the wind side, it was a lot more obvious because the majority of these assets had power purchase agreements already in place, but they were yet to start construction as of the start of the year. On the right-hand side, there was none from the solar side that had PPAs. More recently, we have seen the announcement at Wellington North. You've also labelled here the VRET2, so that's the Victorian Renewable Energy Target Auction 2. So they will announce the winners of this auction. That's 600 megawatts AC. 600 megawatts AC in capacity, and so we expect another 600 megawatts AC to start construction as well over the next 6 to 12 months as well. However, those were not the only projects, those were just our forecasted projects. What you're seeing on screen here is the total amount of capacity that has started construction from 2015 to 2022 for utility PV in the gold, wind in the blue, and lithium-ion batteries in the purple. The industry in Australia really kicked off in 2017, despite the fact that we had some pilot and smaller scale projects prior to this. This was a time in the Australian market where we had high wholesale energy prices in the market. We also had high prices for large scale generation certificates, which you get awarded for generating megawatt hour of electricity. So effectively improving the economics of utility PV and wind projects. And all of a sudden we had as well auctions and PPAs being handed out for PV and wind assets as well. And so the industry really kicked off. Moving into 2018, we had quite a number of assets starting construction each year. And we really started to see some of the issues with regards to construction and commissioning in the second half of 2018. So we saw cost overruns, particularly on utility PV facilities, which really started to hurt a lot of the EPCs, with the most notable or perhaps memorable incident being the bankruptcy of RCR, noting that they effectively went bankrupt on cost overruns on solar farm. And then moving into 2019, we had marginal loss factors being downgraded quite substantially for utility PV and wind assets. And this again diminished the economics of utility PV and wind new build. And then in 2020, we had the bushfires over the summer, and as well as COVID obviously hitting the markets. In 2021, we've begun to bounce back, with the key notable story here actually being utility scale storage, which we'll talk about as well later, really hitting its stride as to the first year of a gigawatt starting construction, as well as utility PV continuing on. And in 2022, thus far, it's been all about wind. So it's already a record year in capacity terms for wind. It's also worth noting that the number of assets continues to decline year on year, but that's just because the capacity and the size of the assets is getting substantially larger. As we saw in the previous slides, there were projects of 400 megawatts AC and above. We're presenting the same data here. So this is just the amount of onshore wind on the left and utility PV on the right that has started construction each year. And it's just displayed, instead of being color-coded by technology on the previous slide, it's color-coded by the state in which it's located in, just to highlight some of the geographical trends. And we see here in the early parts of the boom from 17 to 19, the wind was largely concentrated to Victoria, and has since moved more recently to Queensland, and utility solar has really been underpinned by Queensland and New South Wales. Moving on to who are some of the key names in the Australia utility PV markets. So on the left-hand side here, you see the top utility PV asset owners, and this is the equity share of the assets. Lightsource BP has recently moved to number one, with the announcement that Wellington North and Whanganui have started construction and will take financial close later this year. French independent power producer Neoen is number two. And then you go through down the list here of some key names that were mentioned earlier. And it's also worth noting that utility PV in Australia is very much international developers in the market here. They're really the ones that dominate this list. There's actually no local company in the top 10 at the present time. On the right-hand side, you see the top utility PV module suppliers, again, broken down by the amount of capacity under construction or in operation, of which JA is one of the top companies in this market. Moving on to some of the challenges in the market. So with such rapid amount of build out as we've displayed before, we are starting to diminish our network capacity in Australia available for new connections. And what I'm showing here in the chart on the right-hand side is Transgrid, who are the transmission system network operator in New South Wales, effectively our largest state in terms of electricity consumption, shows their indicative capacity for new connections over time. And it's fallen like a stone in pretty much all regions of New South Wales. There are a few projects that will still have their letter to connect and will move ahead later this year. But as you can see here, just how rapidly we've diminished the network as this boom has taken place in New South Wales, and this is similar in other states. So we need to build out the network, and we need to do it fast. And a lot of the transmission work has already begun, but a lot of the bigger upgrades won't finish until the mid to the second half of the decade. A second key issue that I'm sure I probably don't need to make the audience on this webinar familiar with is just the fact that the capex has increased. So obviously utility PV has not been immune from cost increases across the world. And what you're seeing on screen here is an image from data pulled from our Renewable Cube software. And this is just the utility PV capex for projects between 50 and 300 megawatts AC globally. It's broken down into the different cost categories on the right-hand side. And the only two key ones that I'll touch on here are the solar module, which is obviously the biggest individual item when you break it down into this detail. And that has risen quite substantially since 2020. Shipping as well has been up sixfold as well since 2020. So quite a substantial cost increase in these two components. They're obviously not the only two components that are causing this cost increase, but obviously this is a negative when the first is you need land and solar or wind resource. That's pretty easy to come by in Australia. The second is that you need a transmission connection point to get your electricity to market. Now that's, as we've seen, already fairly difficult, so we're upgrading the grid. And then the third is that you need a power purchase agreement to have certainty of revenue that the banks will lend you money to get your project across the line. There are a few companies that do not need this, those that are the bigger utilities around the world, where this is where any individual project is relatively small part of their balance sheet. But for most proponents, they will need a power purchase agreement to get debt and move their project forward. So obviously a lack of PPAs for utility PV projects is effectively a negative for utility PV. The opportunities, though, it's not all negative, and these are just short-term challenges that we've just discussed. Australia is about to go through a rapid transition away from coal towards PV and wind. We're just highlighting one example here. This is on the right-hand side, the generation in New South Wales, our largest state by electricity consumption. And in New South Wales, we are going to see 4 out of the 5 coal-fired power stations in New South Wales exit the market in the next 11 years, with AGL's Liddell, 2 gigawatts, and Origin's Eraring, almost 3 gigawatts, exiting the market between now and the end of 2025. And just to highlight how much they contribute to New South Wales generation, you can see in the grey colours on the right-hand side. It's an enormous amount of generation exiting the market, and it must be replaced. And this is where we're going to have transmission upgrades and utility PV, rooftop PV, and wind largely replacing the bulk of that energy generation. So it's a huge opportunity to come over the next decade in New South Wales. The next one that we've already mentioned is the Victorian Renewable Energy Target Auction 2. The results will be announced by the end of Q3. On the right-hand side here, you see a map of Victoria and all the solar and wind assets that are pre-financial close. We've also here color-coded the Victorian grid into 6 regions with the existing network capacity as defined in AEMO's, that's the Australian Energy Market Operators 2022 Integrated System Plan. There are 3 key parts of the grid where you have a lot of network capacity remaining. The Gippsland in the southeast, which is where the coal-fired power stations are, but there's largely not that many projects there. It's quite densely populated. And then you have the northern part of Victoria in the blue, and the southwest, which is largely where the wind projects are in the southern part of the state. Now, Victoria already has a substantial amount of wind capacity already energized at over 4 gigawatts. And by comparison, there's about 1 gigawatt of utility PV. So we believe that this capacity in this auction will largely go to utility PV. It's a relatively underpenetrated state in utility PV. And if we look more specifically at the projects that are in the northern part of Victoria that are solar, here that are pre-financial close, that's what's shown in the map on the right-hand side of the screen. And just the top 10 proponents in this region, not all of them, are highlighted on the left-hand side and their corresponding projects. So we think that the winners will largely come from this list. And this list of companies should look familiar because a lot of these companies were in the top 10 asset owners that we showed before: Neoen, Lightsource BP, AC Energy, Excelio, Versal, as well as Pacific Hydro, quite a prominent wind developer in Australia, and they also have a solar farm in Queensland as well. And with that, I'd like to thank you all for your attention, and I'll now hand back over to Mark.
Thank you, David, for your insightful presentation and interpretation. Next, to talk about module technology development direction, we have Technical Manager at JS Solar Australia, Mr. Andrew Jai. With his electrical engineering background, Andrew has obtained 2 master's degrees in engineering, management, and information systems from the University of Melbourne. For the past 9 years, Andrew has been working in the power distribution and renewable energy industries, where he primarily engages in pre-sales and post-sales technical clarification and consultation. Thank you for joining us today, Andrew.
Thanks, Mark. I'll start sharing my screen, and hopefully my screen is sharing.
Yes, we can see.
Yeah, thanks, Mark. Yeah. Today I'd like to explore one of the most optimized solutions to lower the LCOE from the solar module supply end, which is the high efficiency PV modules. Before I start, just a bit information about the solar cell technology. As we know that the mono-PERC, the P-type mono-PERC is still the current dominating and mainstream solar cell technology. And it seems that 24% is the it's kind of the bottleneck of the efficiency, and then that's why we need more options, the alternative options, and we have the N-type one. The TOPCon technology with N-type is can bring us like 1 or 2% higher solar cell efficiency, and also the production line is like compatible with current P-type mono-PERC production line. That means we can easily upgrade the P-type mono-PERC production line to N-type TOPCon. And for the IBC technology, it's kind of the back contact technology, and that means there wouldn't be any busbar on the front surface of the solar cell. And even the efficiency is about like 1% higher than TOPCon, but the production processes are completely different with current facilities. That means it's not compatible, and it will be with a high transfer cost. And the tandem solar cell is one of the promising solar cell technology, and it's also called the next generation solar cell technology. It could help us to break through the solar cell efficiency. We can see here we can reach 29% by the end of year 2025, and even as far as I know, in some of the laboratory, the rate is even higher than 30%. And this is the first product I'd like to introduce to you guys today. It's JS Solar DeepBlue 3 Pro series, and this module is featured with Presume Plus technology, which is the most advanced solar cell technology with mono-PERC technology. And also the panel is featured with the GFI technology. It's a gapless flexible interconnection, and I'll illustrate this technology in the following slides. And the panel is also with the optimized M10 wafer, and the wafer is doped with gallium. That means with the gallium doped wafer, we can offer very sharp, the lower LID, which is 1.5%. And also the module is featured with the most proven and reliable technology like half-cut cells and multi-busbar. Here is 11 busbar. And speaking of the GFI gapless flexible interconnection technology, it's JS Solar patent module encapsulation technology. It's with round ribbons with the cushion configuration that can achieve the gapless connection between the solar cells. And the round ribbon with cushion can minimize the mechanical stress at the connection point, thereby eliminating the micro cracks. And on the other hand, this technology can boost the module efficiency a little bit, and apparently it can improve the module appearance a little bit. So for the CNI and the utility scale solar projects, we do have 72 cell and 78 cell, 2 different formats, and both bifacial double glass and monofacial modules are available. On the 72 cell one, the power cuts could be 560, and on the 78 cell one, the power cuts could be as high as 605 watt. And we do offer another product for the residential market, which we call it the Light series. And there are two different modules. This one is with the either silver or black frame, but with a white backsheet. So the part class is 415, and it's 1.7 by 1.1 meter, and it's 21 kilograms. So this dimension and the weight is very friendly to the local installers. And speaking of the power class, the 415 and 390 watt, these panels are very ideal and perfect for the Australian local residential market. This could help our customers to maximize the STC points claiming and also the maximize the system performance. Also, here is something I'd like to introduce and highlight most. JSolar, we recently announced the 25-year product warranty on this series, on the Light series of product for residential market. JSolar is one of the very few company can offer 25 years product warranty on residential market. That means we can give the customer the peace of mind, 25 years lifelong time protection. You can just have the panel and you have 25 both product and performance warranty. And we have also done some reliability testing according to IEC standards. We can see that there's a standard testing of dump heating 1000 and TC200, but we also do the enhanced testing with double the IEC testing conditions and standards. So the power loss for the standard testing is within 2%, and the power loss for the enhanced testing is within 3%. The requirement from IEC standard is less than, not higher than 5%. That means the JSolar, we do have the quality control from our side is far beyond the requirement from IEC testing standards. And after the mechanical load testing, we can see that there are no micro cracks on the EL images. On the PV system design and development side, we can also help the customer to having savings on rack usage, inverter cost, construction cost, and cable usage, as well as labor cost. So overall, we can have a lower LCE by 3 to 4% lower. And this is based on a simulation of 100 megawatt project in Dubai. So eventually, as I mentioned previously, so the value is added to the customers end with DeepBlue 3 Pro by offering the better performance and higher reliability, and also with a lower LCOE. So in terms of production capacity, as my colleague Cameron has previously mentioned, this year we will have 50 gigawatt of module production. And so within this 50 gigawatt, 20% of them will be DeepBlue 3 Pro. And next year, it will be 80% of them of DeepBlue 3 within that production capacity. And following the P-Type Pro, and this is another product I'd like to introduce to you guys today. It's JSolar N-Type solar modules. There are 3 different formats. The 54 is for the residential market, and the 72 one and the 78 one for the CNI and the utility scale solar projects. As we can see, the highest power class from the 78 one could be 625 watt. And the N-type solar modules will be featured with Bi-Zoom Plus solar cell technology and JFI technology again, and also multi-bus bar. And the N-type solar modules will be with benefits of low degradation rates and lower temperature coefficient, high bifacial factor, and also the better low light performance and high power class. So I will illustrate all these features in the following slides. The first, the Bi-Zoom Plus solar cell technology. This is the JSolar patent N-type technology with passivated contact based on the M10 silicon wafer, and we will have the higher VOC and the higher efficiency of 24.8%. And the JFI technology again, but this time we upgraded the bus bar from 11 bus bar to 16 bus bar. So this will help us to increase the current collection and the current collection ability and the effectiveness, thereby boosting the power class a little bit. We can see from the roadmap that for the 7201, the N-type module will have 575 watt power class, and the 781, 625. And the power class will be lifted to 25 watt, and the efficiency will be lifted more than 1% higher. Another key innovation on the N-type solar modules is it will have lower degradation rate. We warrant that for the year one, the degradation will be less than 1%, and the year after, annually, it will be less than 0.4% throughout the 30 years performance in life. That is the factor that due to the factor for the N-type solar wafer, it doped with phosphorus. There's no BO complexes. And what does BO complex mean? It's the boron oxygen complexes. This happens on the P-type solar modules. For P-type wafer, it was either doped with boron or gallium. So there will be BO complexes, and this is what triggers the LID. Without this one, the N-type is really LID free and no LID degradation like P-type. So like in previous slides, after 30 years performance, the N-type solar module will still have 87.4% of the nominal power. And another feature is like for N-type solar modules, we will have the lower temperature coefficient for the maximum power. Compared with the P-type, the coefficient is slightly lower. That means the performance reduction related to the temperature will be slightly lower than P-type. And this is another key innovation of N-type solar modules. The bifaciality is 10% higher than P-type. That's why we say the N-type solar cell is ideal for the bifacial modules. So if the albedo on the ground is about 10%, you get about 1% higher performance. That means the 10% or 1% higher bifacial gain from N-type solar modules than the P-type one. And another feature for N-type is better low light performance. What does the low light performance mean? We all wish that the every day in a year is sunny. That will help the solar system to perform much better and its 100% condition. But not all days are sunny, and some days are cloudy, and even in the morning or in the late afternoon, the sunlight is very low. And so that's the panel will not be performing and it's 100% condition. And the lower the sunlight is, the N-type will perform much better than P-type. Giving you the reference, like during a sunny day, the irradiance, the sunlight will be 1,000 watt per square meter. So this is really the very low sunlight, and N-type, and this circumstance, N-type will perform much better. And again, we have done the module reliability testing according to the IC standards, both standard IC testing and the enhanced testing with double the IC standards. So the power loss is within 2% for the standard testing, and power loss is within 3% for the double the enhanced IC testing. And that means we still have very high quality control, which is far beyond the requirement from IC standards. We've also done some performance analysis. We work with TubeNode in China. We have a demo site, and with the data we collected on site, it shows that the N-type module, the JSOLAR N-type module, generates 3.9% higher than the P-type modules. And with the simulation of a 100 megawatt project in Dubai, it showed that we can get the values added to the customer end by reducing the BOS with 2.1% and reducing the LCOE cost 4.6%. And as the latest production forecasting released from the headquarters, this year we will have 1.3 gigawatt of N-type production, and next year we will have 27 gigawatt of N-type. So this should give you this sufficient confidence that we will deliver whatever volume you require from us. That's pretty much it from my end today. Feel free to ask any question that you have. I'll hand it to you, Mark.
Thank you, Andrew. Thank you, Andrew. That was impressive. And if solar panels are the brawn of the solar energy system, then the inverter is the brain. Our next speaker is Jessica Chan of Huawei, and she will be talking to us about Huawei digital technology. Jessica has 16 years of global experience for solar engineering and project of gigawatts EPC design and construction, solar products, and solution planning and prescription. Nice to have you with us, Jessica.
Hello, everyone. Today, my topic will be Huawei digital power, building a low carbon society. Let me just share with my slides now. Talking about Huawei, many people are aware we are quite a globalized company. Last year, we have been ranked number 44 on top of out of the Fortune Global 500. Currently, we have the branch office in more than 170 countries and region. The annual R&D investment has been more than 15 billion USD in the past years. More than half of our staff have been working with R&D department, which is an amazing percentage. Many end users aware we do have the telecom and the mobile phone traditional business, but they maybe not know Huawei also got the power or energy business. Huawei digital power actually have 5 business area. If you are able to see my slides, you can see we do have the smart PV, which is a photovoltaic business. We have the data center facility business. We have the set power business, which is supplying the power to telecom base station. We also have the drive one, which is the smart control module and the energy module for the EV cars. We also have the embedded power business. You can see from the left, our business revenue has been increasing by annual rate about 20%. Huawei digital power has been serving 1/3 of the world's population. In regards to today's focus, smart PV or photovoltaic business, here is a quick look of our business progress. By end of last year, we have shipped more than 210 gigawatts solar inverter. By the way, Huawei solar PV business has been focusing on inverter and storage manufacturing and supply. We don't produce PV panel or mounting structure. Huawei solar inverter has been used in all the extreme environments or the harsh conditions, from the very high temperature to the very low temperature, all the salty or humid environments, or even the world's highest altitude environments. I mean, our inverter are up to 4,000 meter altitude, no degradation. In regards to the annual shipments, we have been ranked #1 for the past 7 years, according to third-party IHS and Wood Mackenzie statistic. In regards to the solar business industry, my second section is the solar trends and challenge. If you look into the evolution in the industry in the past 10 years, from my slides, you can see the levelized cost, which means the unit cost during the lifespan of the solar system has been optimized or reduced a lot in the past years, with bigger and bigger PV panel and with inverter change from the 1,000 volts to 1,500 volts DC, especially for the solar farm application. And for the mounting structure, before there was lots of fixed mounting structure. Nowadays, especially in Australia, you can see there has been a big portion of the tracking structure. In regards to ORM, starting from the very manual type of ORM, nowadays we see more and more AI automatic feature of the tech. If we get a close look of the 3 key components of the solar system, you can say for the PV panel or PV module, nowadays we see more and more bifacial module application rather than single facial module, especially on the solar farm scenario. Here, you could see some third-party data by this year. It shows estimation of 22% of bifacial module out of all the application, including Resi, CNI, rooftop, and also solar farm. In regards to mounting structure, you could see the third-party feature shows 44% globally, all the scenario. But as I mentioned earlier, for Australia solar farm, obviously you see a bigger percentage, more than 44% for the tracking structure. And for inverter, Huawei, in fact, have been the driving force for the string inverter application into solar farm scenario. I remember when I personally started with this industry 16 years ago, for the solar farm, everyone was used central inverter, right? Because that was the only option at that time. But what Huawei has brought to the industry is actually a revolution of the technology innovation. Go to string inverter. We call our innovation smart string inverter. Why all of this change happen? We just need to get a closer look of the levelized cost of energy formula. When we say this unit cost of lifespan of the solar operation, there are capex, opex, and also the output as the 3 key factors. If you want to optimize your levelized cost, unit cost of energy generation from renewable energy, you need to reduce the capex, reduce the opex over the 25-year lifetime, and also you need to try to maximize your 25 years power generation. But these are the 3 key factors we want to look at and work on. So let's talk about it one by one. First, for the PV cell innovation, you can see the third-party data on the trends. Currently, the P-type PERC module are still the mainstream product, but maybe 5 years later, you see the yellow color bar. It shows a big increase of the forecast of the N-type new module. Eventually, it could take up to 50% of the market after 5 years. But why of this evolution? It's typically because the new module technology brings a higher power, higher efficiency, and it brings a low degradation. Also, as Andrew just explained, it has a low light, better performance. So all of this advantage help improve the levelized cost from the system level. If we look into a detailed example of the levelized cost of system of the N-type module, from this figure for solar farm and residential rooftop respectively, you could say a higher efficiency module or higher power module, naturally it could minimize the area of the panel, right? Then it could minimize the cabling cost and the mounting structure cost. So it's reduced the BOS capex. Also, with the better efficiency and low light advantage, and also the better degradation future, it can also improve the output, right? So this goes to another factor of the levelized cost of energy in that formula. And if I move to the second component of inverter, which is Huawei solar business focus, let's look back to the history of Huawei's success of our technology. When Huawei R&D team designed the product, including the solar farm, we didn't follow the traditional trend. We use our own innovation for the multiple MPPT design, smart strain inverter. Traditionally, our inverter has only 2 PV strain inputs for per MPPT. The advantage is because the mismatch losses in the solar system could come from all the angles, right? Even a tree leaf, a bird drop, or the workmanship deviation, all type of mismatch can cause the different output of each solar panel and each solar strain. And with the traditional centralized solution for solar farm, there could be more than 100 strain combined into one inverter. And one inverter, like let's say 3 or 4 megawatt central inverter, have only 1 or 2 MPPT. All of these mismatch losses have reduced the output. But with our innovative design of only 2 strain per MPPT, only this 2 strain of panel, maybe 60 units altogether, could affect each other performance. In that way, the output of the system has been improved. On my slides on the right part, you could say a typical comparison for different type of tech. Typically, we say roughly 2% output increase with this multiple MPPT design brought from Huawei. With this type of design, it's not only about output, also about the OPEX and CAPEX minimization. Because traditional central inverter, although the inverter quantity is less, but with so many strain, usually there are DC combiner box and DC fuses. But with the new technology of 2 strain per MPPT, we can limit the reverse current to only 1 times, right? So these are usually within 20 amp and within the reverse current capacity of the PV panel. In that way, Huawei innovation has managed to eliminate the use of the DC combiner box and DC fuses. Also, there will be no more maintenance of the DC fuses, right? The next output increase or availability uptime increase point is about the concept of this strain inverter. Because Huawei has been promoting this replacement only concept other than the traditional complex service agreement for the centralized solution. Because as we all know, especially for solar farm, if some issue happened with the central inverter, if it's level 1, level 2, or basic level faults, the normal electrician could do some troubleshooting with the training received from the manufacturer. But if it's level 3, level 4, or high level fault, the owner operator could only wait the engineer from the manufacturer to go to site to do the troubleshooting. And sometimes it takes 1 month, 2 months to fix the issue. And that is a big power loss for the central inverter, megawatt scale. But for Huawei inverter, we usually recommend customers to store some spare units on site. So if there is some issue happen with the inverter, our team support with the remote troubleshooting. If it's confirmed it's inverter fault, there could be an immediate replacement with the on-site units with the normal labor. You don't need the very complex scale engineer from the manufacturer. So in that way, we also typically increase availability time with 2%. This is also optimization of the output of the solar system. Another innovation I'm showing here is about the operation itself, or the MPPT curve itself with Huawei. You can see a comparison here. Our solar farm inverter typically have a MPPT voltage range from 500 volts to 1500 volts. With other tier 1 inverter, typically starting from 650 or 850. This means Huawei inverter can wake up earlier in the morning and sleep later in the evening. In that way, you also get some better outputs every day. With all of this innovation, you could see the third-party data summarize the accumulative shipment of totally 210 gigawatts in our past 10 years solar business, which is a huge success. After inverter, I'm going to the next component of mounting structure. Since most people already know in Australia, the tracking structure is widely adopted. I'm not going to talk that too much. What I'm going to highlight is the advanced feature of our inverter smart integration with the tracking structure. Because as we all know, the structure manufacturer, they will use their own algorithm to control their structure. But actually the control and calculation as the inverter inputs is based on the power value of PV string, right? So this means actually the inverter manufacturer could have the chance to do the very accurate control and boost of the output of the tracker inputs, other than the traditional way by the tracker manufacturer calculating from the input or output of the PV panel. That's why Huawei has launched this feature. What we call it SDS, which is smart integration. Basically, we use our foundation R&D technology, which is AI boost. This algorithm has the self-learning feature. It can automatically calculate the historic performance data of each system and to give a better control command to the tracker controller. This is another interesting point, combining the inverter and tracker combination. Okay, so this is my last page, which shows some interesting testing. With all the above innovation of technology I have talked, the last highlight is always the quality, right? Huawei has a very big R&D facility. So with solar business, we quickly leverage this resource to solar. The testing I was playing through the video was actually a real rocket trigger lightning testing. This is for testing the performance of the surge protection device instead of our solar inverter products. This kind of money-burn testing obviously improves the accuracy of the product design and quality, but it's not easily affordable by some small company. For Huawei, traditionally, we do this kind of telecom level reliability testing for the telecom device. So we could take the same facility to test the solar inverter. That's why Huawei has been maintained the position of the only telecom level reliability testing as the solar inverter manufacturer. In this page, besides this kind of fancy testing, it also shows other typical testing, like the low temperature testing, high temperature testing, like the salt debris testing, salt mist testing at the lab. With all of this quality control together with the above technology innovation I have talked, this has explained the secret of Huawei inverter business success. And the last page, just add on Huawei digital power at end of 2021. We have already helped our customer generate with more than 480 billion kilowatt hour energy, which is equivalent to more than 310 million trees. Yeah, that's all from my side. Thank you very much.
Thank you, Jessica. Thank you, Jessica. And our closing presenter, David Bo from QSUD Greater China, will be speaking about key technical points and data of PV module reliability test.
Oh, I unmute. Thanks for the introduction of the moderator. Can you see the screen now?
Yes, very well. Thank you.
A moment. Okay.
Good afternoon, everyone. This is David from the TV South China. Today, I will want to share you the presentation is about the key technical points of reliability tests and eco design. From a technical view, as you know, we usually consider three key points when we design PV module, which are safety, reliability, and eco design, in which reliability is the basis and prerequisite of safety and eco design. Safety module can be designed according to standards IEC 61, 730-1 and -2. Eco design is related to the environmental protection, which has been a market interest in recent years. In the following step, I will focus on the key technical points of reliability tests and eco design. Reliability is defined as the probability that a product will perform its intended function adequately for a specified period of time, or will operate in a defined environment without failure. The environmental condition is variable. There are many kinds of climatic stress factors, which have influence on the PV module reliability, as the left figure shows, include the irradiation, temperature, and so on. For PV module, the intended function is to produce electricity. The specified period is lifetime, usually 25 years, 30 years, even 40 years. In this period, PV module is required to generate enough electricity. There are two key points can be used to estimate the electricity generation capacity in the lifetime. One is the first year energy yield, and the other is the power degradation rate. I will introduce how to determine the first year energy yield when we talk about eco design. The red figure in this slide is a degradation curve example of GA product. We can find the first year degradation here and the annual degradation rate in the following year. The actual degradation rate will be determined by the module design and external environmental factors such as climatic stress factors. IEA means the International Energy Agency, who make a review of failure of PV modules. In the paper, PV module failures are divided into 3 stages: infant, midlife, and wear-out failure, as shown in the figure. In different stages, there are different typical failure phenomena. In the infant stage, design defects will lead to failure quickly, such as loose fan and the PID. Other degradation, such as EVA discoloring and the delamination, will lead to the final failure in the midlife and couldn't achieve the warranted lifetime. Ideally, we can design some appropriate accelerated tests to verify the module meets the reliability and safety over its lifetime. But it's difficult for PV module. We can find it from the definition of the accelerated testing, which is defined as a process of testing a product by subjecting it to conditions in excess of its normal service parameters in an effort to uncover faults and potential modes of failure in a short amount of time. So it's critical to find adequate acceleration factors, but we shouldn't be fully aware of the failure mechanism of a PV module. It has not yet been achieved now. Thus, the design decides may be false positive or false negative. Besides, There is also no unique factor number of delineating the equivalency of the test time to service time, since different materials and application environments factors. So it's not an easy task to design a operator accelerated lifetime testing for PV module. However, the industry experts never stop making efforts in this field. For example, based on Norris Landsberg mode, some cycle test 500 is roughly equal to 25 years, which is based on the soldier bound fatigue mechanism. There are many test standards as published in the IEC, which are mostly think as qualification tests, because they only use these tests to find early failures in the infant stage and to screen new designs and new production, that is susceptibility to non-failure mechanisms. Here, I list the acceleration tests the industry usually care about. The left column is the test commonly used in our experience, and the right column is used by only a few manufacturers currently. There is an important specification need to address here, means IEC TS 63209-1-1. This technical specification is intended to provide supplemental information to IEC 61215 from view of long-term reliability to align the variants of extended stress testing protocols to reduce test costs and time for the industry. And as you know, there are many different testing protocols in the market from different institutes and test levels. This technical certification is also intended to apply different test sequence to provide information for comparative qualitative analysis using stress relevant to application exposures to target non-failure modes. This is the test sequence. Each test sequence is corresponded to different failures. For example, the 6.1 is the TC is a thermocycle test, as mentioned before, which in general 400 to 600 cycle thermal test is equal to 25 years lifetime. But this standard is not to evaluate the module lifetime. This slide shows currently reliability test results of GA Solar DeepBlue 4.0 double glass product in our lab. Some other tests are still be ongoing. You can find the GA product has good performance and only have a few degradation after the reliability test. Okay, in the following time, I will continue to introduce module eco design. Eco design, as I mentioned before, you can think it as the environmental protection, which means considering the environmental issues as this picture shows through the whole product chain with the method of life cycle assessment method. Left figure shows the life cycle concept. Right figure shows in fact the environmental issues. Approximately 80% of all module all product related environmental impacts are determined during the product design phase. Considering environmental aspects in the design phase is effective approach to improve the product. So The European Commission is already drafting eco-design directive related to the PV modules and inverters. The requirements are listed in this table. We can find that the purpose of the eco-design directive is to guide the industry to design products with characteristics of high efficiency, less degradation rate, with high reliability and repairability, and also can be recycled, and no toxic materials. This can, and also the carbon footprint I will introduce in the next slide. This can help us to reduce the environmental impact of the PV module. For carbon footprint, the plan is implemented in 2 stages. The first stage is the module carbon footprint shall not exceed 25 gram carbon dioxide equivalent per kilowatt hour, which means the purpose is to phase out the efficient multi-crystalline silicon technologies. The second stage, this value will be decreased to the 18. The purpose is to phase out the inefficient monocrystalline silicon technologies. And it should be mentioned that the carbon footprint only considers the impact on climate warming. And there are still many other environmental impacts shown in the slides before, which are usually considered in the EPD. EPD means the Environmental Product Declaration. There are 2 kinds of EPD registration or program, means international and national. Different national has their own EPD platform. The EPD between the national and the international platform may have a mutual recognition agreement in some cases. In PV industry, Italy market has now asked customers to provide the EPD certification in funding of a PV plant project. As I know, GA Solar has get the EPD Italy registration, and also get the France carbon footprint certification. This slide, I would like to introduce the energy efficiency index. The eco-design directive specifies 3 typical climatic conditions in Europe. The PV module is classified based on which range the energy efficiency index value is looked in, as this tab shows, and be classified for each climatic condition. With 3 climatic conditions. The energy efficiency index is calculated by dividing the DC energy yield of by the module area, when assuming no degradation, and that the installation conditions are also specified. Therefore, it's critical to calculate the DC energy yield of PV module over the first year. The calculation method refers to the IC 61853-2 following this process. Once the energy efficiency index has been calculated, it needs to be reflected on the energy efficiency label. Energy efficiency labeling is a new equipment in the European Union, and will be used in combination with eco-design directive. The purpose is to let consumers understand the energy efficiency level of PV modules, then choose products with high energy efficiency levels, and eliminate products with low energy efficiency level. It's mentioned that the energy labeling regulation is not applied to all kinds of PV modules. There are some exceptions, as this slide shows, such as the BIPV, such as the smart module with integrated micro inverters. Okay, that's all I want to share with you today. Thanks for your attention. Thank you.
Thank you, David, for your presentation. And that brings this presentation portion of our webinar to an end. Thank you, everyone. And of course, the recording of today's presentation will be posted for future reference. Thank you for posting your questions. Now let's move on to the questions. First question for David Daxin at Riset Energy. Which stage do you see the utility PV being built in now that New South Wales grid is full, and why?
Great, thanks for the question, Mark. It is certainly a concern that the grid capacity in New South Wales has gone to zero so quickly. There are still a handful of assets in New South Wales with a letter to connect, which means that that capacity has been accounted for in the slide I showed earlier, but those assets are yet to start construction. So certainly there will be perhaps in the order of 1 gigawatt still to start construction in New South Wales. We certainly expect in the short term for capacity to start construction in Victoria, which is to the south, and Queensland, which is in the northeastern part of the country, to take over in the short term. But long term, the two really key markets where the majority of the capacity is going to be built are New South Wales and Queensland. And as those grid upgrades that we discussed in the presentations begin to finish completion from 2024 through to about 2028-29, development will certainly move back to New South Wales. Can't hear you, Mark. Sorry,
my bad. Thank you for your answer. And another question is, what is the impact of storage on utility PV uptake in Australia?
Yeah, another fantastic question. And for those that might not be so familiar with the Australian market, the Australian Energy Market Operator forecasts that by 2050, we will supply somewhere between 44, 45%, or 52%, somewhere in that range of our generation from solar. And so obviously the sun doesn't shine over 50% of the day at full irradiance. So we need to store, one, overbuild, and then two, store some of that solar energy into batteries and pumped hydro. And for that, we are forecasted to need somewhere in the order of 70 to 80 gigawatts of storage in order to enable this PV to be built. And right now in Australia, we have less than 3 gigawatts. So there's a long way to go, but it's essential and critical that we build this storage out to enable this PV development to continue on in Australia and to decarbonize the electricity, grid in Australia.
Very well, thank you, David. Moving on to Jessica from Huawei.
Yes.
Hi, Jessica. I have a question. Has Huawei got reference cases of inverters installed for large-scale solar farm located in Australia? What could be the biggest technical requirement difference between Australia and other Asia-Pacific courtier markets for inverter application for solar farms?
Yeah, thank you. The answer is yes. We have the reference already for the large-scale solar farm. In regards to the largest difference between Australia market and other markets, technically, I think it could be the strict requirement of the grid modeling and approval. As some of you may be aware, Australia is what we can call it a weak grid country. So the infrastructure now is not easily connected with large-scale solar farm with large-scale grid impact. That's why Australia, AEMO and NSP has imposed more strict modeling requirement compared to all of the other countries, what I can say. There is very interesting process of GPS R1, R2 process in Australia before the project finally reached the full operation and COD. So Huawei has the full cycle reference already, including GPS R1 and R2. I can say altogether in Australia, there are less than 5 inverter manufacturers have this reference of large scale, and Huawei should be the only one from China. Yeah, hope I answered this question.
Thank you. And the second question, in regards to inverter availability, what's the difference between central inverters and Huawei smart string inverters?
Very good question. As I shared in my earlier slides, the higher availability or the higher uptime of inverter operation is in our design DNA of our smart string inverter, because we are based on a replace mechanism, but not a repairing mechanism. If there is really some issue happen for the electronic instead of the inverter, the replacement by some normal scale electrician or labor can be as short as 10 to 30 minutes for each 40 inverter. So the overall availability, naturally we see global experience are more than 99.99% on average. While if you compare with other traditional centralized solution, what do they guarantee for the inverter availability? They may offer starting from 97 availability guarantee. You have to pay extra to get higher availability and support from them. But typically we say maybe 1 to 3% availability difference between smart string inverter and centralized inverters. Yeah.
Thank you, Jessica. And now we are moving to Andrew.
Hey, Mark.
Hi, Andrew. Question for you. From your point of view, will N-type solar cell technology take over P-type, and when would that be? What's the next technology that would take over N-type?
That's a good question. Yeah, actually, from my side, the answer is yes, definitely yes. And the only thing that matters is when. So what I have seen on the market, N-type is picking up much faster than we expected. And in the next 2-3 years, we'll have more production capacity on N-type. And the thing, the market and not only the supply, the market is are all waiting for a breaking even point. And once the price difference between the N-type and the P-type is less than 1 US cents, and that would be a time and the customer are more keen to switch to N-type. So that will happen probably in the next 2-3 years. And after 3 or 5 years later, there will be a technology which I have introduced in my slides, and it's a tandem solar cell technology. That will be the technology that replace the current solar cell technology from the silicon wafer.
All right, very well. And they're both G12, which is 210 millimeter wafer, and M10, which is 182 millimeter wafer, existing on current market. What makes you, as JS Solar, promoting M10 modules rather than G12 ones? What are the differences between PV modules and these two different wafers?
Yes, answering this question, I'd like to explain why there are two different wafers, like the most mainstream wafers, and they are coexisting and competing with each other. The principle for the 210 millimeter wafer is from the manufacturing side. It's introduced by the semiconductor manufacturer, and the 210 millimeter wafer could minimize the cost from the manufacturing end. You know, the silicon wafer is not only the material for PV modules, it's also the material for IC chips. So the entire semiconductor industry, we could minimize the cost. And the M10 wafer, the one we are promoting, the 182 or 182 millimeter wafer, is introduced by a solar panel supplier like us, J. Longi or Jinko, and we designed this like dimension wafers to optimize the system performance and also minimize the risks on site. That's why we see that the M10 wafer, the one we are promoting, will bring slightly high performance and a lower cost, and also the less risks on site.
Very well.
Yep.
Thank you, Andrew. And now we are moving to David Bo at TUB. Hi,
Hello.
David.
Hello, Mark.
Okay, question
Yeah.
for you. Could you please further introduce the process calculating first year energy yield of PV module?
Okay. Maybe I need to share my screen thing. Could you see the screen now? Okay. It's a complicated process. Firstly, we need to get the typical climatic profile, which means meteorological data. The format is defined in the IEC 61853-4 standard. Then we need to correct the irradiation, consider the influence of the irradiation angle, which can be referred to the IC standard IC 61853-2. The second step, the third step is also to make the irradiation correction, which is used to consider the spectral mismatch. As you know, the spectra of the solar, the sunshine in the is different from the AM 1.5 spectra in the STC condition. So we need to consider the spectral mismatch. While we need to use the spectral response of the PV module, which can be measured according to the method described in the IC standard 61853-2. The first step is to determine the module temperature. Module temperature is related to the solar irradiation and the wind speed. The relationship between the parameters I mentioned is also described in the IC standard 61853-2. When we measure the NMOT value, based on the irradiation and module temperature we get from the steps above, then we can calculate the module power, the timely module power, based on the where we also use test results method from the IC 61853-1. Then we can integrate the power and the time. And finally, we can calculate the energy yield and the annual energy yield. Yeah, that's all. Yeah, thank you.
Very well, thank you, David. And that was impressive. Once again, JS Solar would like to thank the audience, as well as Rising Energy, Huawei, and TÜV for making this webinar possible. We wish you all success to your business operations. And first of all, we would like to wish you good health and good time to you and your family. Thank you again.